Hello and welcome to CircuitShepherd. To start the tutorial, we'll do some simple but very important examples. First, we show how to synthesize any arbitrary resistance value with two parallel resistors. From there, we transition to voltage divider design, do a short introduction of Thevenin's theorem, and show how CircuitShepherd can be used to synthesize any arbitrary voltage source with inner resistance by corresponding voltage dividers. After starting CircuitShepherd, we can create our first circuit by tapping the plus button in the top left corner. From there, we can choose different template circuits to start from. Templates are just working examples which can be used as a starting point for your own modifications. For demonstration purposes, we start completely from scratch by selecting the empty template. To add parts, tap again the plus in the top left corner. So let's choose our resistor here. Once tapped, we'll get a preview of the chosen part at the bottom and can do the rotation and flip adjustments. Finally, to place the part, just drag it into the schematic. For the second resistor, just do a copy of the first, flip, and place again. We tap the wiring mode button to enable the wire tap points. Drag and drop a wire tap point to place a wire. Tap wire tap points to delete wire segments and solder points if desired. To measure the parallel resistance, we place an ohmmeter. So now we want CircuitShepherd to find the best available resistor combination for a specific target resistance measured by the ohmmeter. Select the ohmmeter to get access to its properties. Enabling the goal checkbox means that the measured resistance should contribute to the overall design goal specification of our circuit. This allows you to specify a target value and corresponding tolerances. For now, we leave the tolerances at default, and just specify that we want our measured value to be, for example, 17 kiloohms. Additionally, to get the underlying AI algorithms working, we need to explicitly specify which parts should have auto values. In our case, both resistors should be automatically determined. Once the circuit is set up, we can change the target value on the fly, and CircuitShepherd will take care to update the part values accordingly. This part is solved so far. Now let's take the next step and modify our circuit to a voltage divider. Let's just do a little rearrangement here. This is still the same circuit as before. Simple parallel resistors. Now let's drop in a voltage source and see what happens. So the result of the ohmmeter stays the same, regardless of the voltage source. The ohmmeter doesn't care about constant sources in linear circuits. Or more generally speaking, ohmmeters in CircuitShepherd always determine the inner resistance linearized around the actual operating point. Okay, now the voltage source determines the input voltage of the voltage divider. So let's drop in a voltmeter to measure the output voltage. Additionally to the inner resistance, we also want to specify a target output voltage for the voltage divider. As with the ohmmeter, just check goal and set up the desired target value. For a better oversight and validation of the circuit functionality, let's place a DC sweep plot. Specify input source and output meter and drag and drop it into the schematic. This is called a thumbnail plot. If you select a thumbnail plot, the corresponding pinchable plot is shown in a resizable overlay. Use pinch and drag gestures in the pinchable plot to define the axis limits. You can pin a pinchable plot so that it stays visible if the thumbnail is deselected. The pinned plot shows a cursor if a corresponding meter is selected. So now, let's investigate the all-important Thevenin's theorem and how to determine and synthesize Thevenin equivalent circuits. Well, the good news is that we are already done. Thevenin's theorem says that, from the perspective of a single output, any linear circuit can be replaced by an equivalent voltage source with inner resistance. The corresponding values of the so-called Thevenin equivalent of our voltage divider are already given by the meters. However, the important point is, roughly speaking, that we can now easily synthesize any voltage source with inner resistance by designing a voltage divider, just by changing the target values of the meters. Okay, so let's keep simple things simple and finish for now. More stuff in the next videos. Thanks for watching. See you later.